Today we're going to be talking about not only SQL or NoSQL. And so to get started here, NoSQL is basically a term that was coined around 1998 that was used in relation to a relational database that didn't really have a SQL interface to it. And over a period of time, it's changed somewhat, and it now refers to a different kind of data storage entirely that is still related. And so not only SQL was created basically to deal with some problems associated with big data sets. So those problems were mainly related to speed and scalability. And in those circumstances, standard SQL databases tend to have problems when they grow above a certain size, where you start to hit speed constraints because of things like the way that they replicate for distributed systems. And also there's issues with the fact that you have this relational model that for some types of data isn't that important, but you still have all the overhead related to it. So those are some of the areas where a standard SQL database can have these limitations. Here with NoSQL, we work with an entirely different model that's based on a key value store instead. So think like if you're used to scripting languages at all, kind of like the idea of a dictionary there, where you have an actual key that could be something like someone's the name of a user for a tweet, and then the value would be the actual text of the tweet, something like that. And when you're dealing with this sort of key value store, you don't have certain aspects such as that you would have in a SQL setup, such as a table, for instance. It's a very raw sort of environment in most cases. And what that allows is it allows for an environment where you have very optimized reading and appending of rows. So you end up getting this very high speed there, and the other options such as deleting and editing rows in some cases aren't even present, or in other cases are much more costly operations. Because of this, it's very, very capable of being distributed across multiple machines, and in fact this is the primary characterization of NoSQL, this ability to be scaled up very greatly and to have really high-end performance. The other thing to realize with this is that there really isn't a relational aspect to it at all. And basically this allows this distribution to be a much simpler operation, much faster operation, because there's all these pieces that are normally in a SQL database setup that are just gone entirely when you deal with this environment. So in relation to this, you have no schema that's really there for your data. So you don't have much metadata that's defined around these key value stores. So you don't really have the need for a schema. This auto sharding is something we'll kind of go over a little bit later. But basically, this is almost like a database partitioning system where in key value stores, your data can be segmented, like the United States data from the European data, for instance, can be segmented automatically by the system. It can kind of figure out how to separate the data out into distributed areas that way. And of course, one of the big characteristics is that they plan on it being queried across multiple machines. And because of its very simplistic setup from the standpoint of its storage, you end up with a very capable caching system. And in fact, that's one of the defining characteristics of these NoSQL-based environments, is that you have very rich, fast caching systems in place for them. Now, I had mentioned the key value stores before, but when you look at this, there are actually different types of data storage combinations available to it. Key value is one. A column family store is kind of a way of emulating a standard SQL-style column format table for NoSQL, but it's a very shallow emulation of that, but it's another way of storing data in here. And the document databases here are for literally doing a key value store where the value ends up being a document, or in some cases it ends up being a piece of JSON or XML or something like that that can be stored in there, so that you almost have like some structured data available in the key value store. And then this graph database we're actually going to talk about a little bit later. We'll go over that. So in this world, we have a few different players. You can see some of them listed here. We're going to find out a little bit about more of them. You'll notice that Oracle has a solution for NoSQL environment that, they're kind of a big player in this field, and we'll find out a little bit more about them. A lot of these other ones you may have heard about being used by various large companies like Facebook, Craigslist. Some of these use these systems that are either ones that they've rolled themselves. I believe Bigtable is one that's that way, or that for some of the others are open source alternatives to this. So why might someone use NoSQL? Well, it's certainly good for storage and retrieval of large amounts of data. When I think about it, one of the places that's pretty easy to understand where people implement it is if they're doing like logging of clicks on various areas on a website. There can just be huge amounts of data coming in, and it's fairly unstructured data that you may want to be able to analyze at some point. But there's basically just data being added on. In that case, you're not even retrieving data, and so it can be very good for that sort of environment. And additionally here, there is, with some of these companies and that have grown so large and providing these cloud computing environments, they're, as these companies are growing, they're looking for different sorts of solutions as their data sets kind of get out of hand, and this became one of those solutions that we have here. So we have with us this morning, well, at least in my time zone this morning, we have with us Anton, which is one of the developers from Mertech here that's had some experience with NoSQL. And so we wanted to talk to him a bit about NoSQL, kind of get some answers to some various questions about how you use it and what it's capable of. Let's let me pull up something here. So Anton, in relation to this, with the various formats of NoSQL databases, you know, I had mentioned there was like the column families and the key value tables, and there's big data. Can you explain some of why there are so many different backends for this, and maybe look at what a graph database is?
Sure. Hello, guys. The biggest, the way I would like to segment the NoSQL world would be big data versus semantic web systems. Big data is the family of database systems that store key values, that store documents, and their emphasis is really on storage the huge amounts of data. Now, the second different aspect of not only SQL is semantic web systems that are, well, they're probably most known as triple stores. Those are the systems where you store data not for the sake of having it in the original form, but rather for being able to analyze dependencies between those. And those systems, they fall into the family of graph databases, although graph databases are not necessarily triple stores.
Gotcha.
So that basically the variety of the databases, it stems from the fact that there are so many different goals there. Sometimes you want to just record a bunch of a bunch of events with the timestamps for later analysis of how many of those events happened during a day, or you might want to analyze who's clicking what. In that case, you don't really care about things like timestamps or the actual count. You are more interested in the relations of objects that the user interacted with and the general proportions of how popular they are from, clickstream, say, point of view. So, and even the big data systems, they are always different because there are so many things you might want to store. Things might be you might have things that are document-oriented. In that case, you might want to choose some of the document-oriented databases like MongoDB. In some cases, you are really interested in key-value storages. There are multiple of those, but sometimes you might want to go even further and say that I'm not only interested in storing key values, but I would like to have another dimension and have multiple versions of the same value to be stored there. That is something that Google came up with their big table originally, and that was replicated in Apache HBase database system, where multiple versions of the same value can go into this fourth dimension.
So, and by the way, if anyone has any questions they'd like to ask, you're welcome to raise your hand on here, and we can get those over to Anton. In relation to something you mentioned a little earlier, Anton, you mentioned this item, a triple store. Can you explain what a triple store is?
Well, triple store is basically a purpose-built system for storing relations. The triple part is subject, predicate, object. Basically, you store phrases consisting of those three parts, phrases being used in broader sense, and then you have an ability to analyze those things.
So like maybe something like Anton likes programming. That sort of thing where you have where you have three items like that.
Yes, that would be a perfect example of a triple. I'm not sure if it's going to be a useful one. Probably the simplest example would be to start with the family tree, because that's like a subject that everybody understands. So if you for instance store information about who's a child of who, then you will get a bunch of basically unstructured data. There is some structure to it because you initially decided that you're going to store a predicate child of. But then if you, for instance, at a later point decide that you actually need another predicate that is sibling, you don't actually have to go in and reprocess your data. What you can do, you can define a rule, that is a term in triple stores. Say if A is a child of B and C is a child of B, then they are siblings. And then you can use query languages like Sparkle, for instance, which is a query language that is used with multiple triple store systems, to query for those rules without actually having to enter any data. You just define certain parameters, certain rules, and then the query language retrieves data according to those rules and according to your queries. So that gives you an ability to record a bunch of different things unstructured or loosely structured, because you might not know what you might want to retrieve, what you might be interested in at the end. And once you figure that out, you just define a bunch of rules, and the data becomes visible to you from the angle you want to look on it at.
So all of a sudden, you almost have some relational aspects to it that you're able to get to by means of the query language that you're using with it, but also based on this predicate style triple storage mechanism. So you're able to almost get some of those relational aspects back that that you give up by going with a system like this, except they're all essentially based on how you choose to look at the data.
Absolutely, absolutely. This is the best example. This is the favorite example of semantic web systems proponents when they try to show their system to RDBMS people. The first example that they are doing, they are taking a relational database consisting of a couple of tables and just show how you can easily do the same in their system, leaving some room for flexibility, for, leaving some wiggle room for other things and defining things as you go, as opposed to having to restructure your data.
Gotcha, gotcha. So it's how they convince all of us that are listening today about why to use some of this. So that makes sense. Now, this sounds pretty interesting. What kind of support is there from the? I mean, I know we have on our slide there that it mentions Oracle has a solution, but what about some of the other big players in this? Is Microsoft in it at all?
Microsoft, I do not know of any Microsoft system. I'm sure that they're coming up with one, but I haven't heard of anything of the same proportion as Oracle's system, or Amazon is a huge player in this field because they have a bunch of databases for various purposes. Oracle, in its turn, they have support for actually both big data and semantic web. Semantic web from Oracle is, of course, sits on top of a relational database. So there are several schools of thoughts on what's good, whether it is a good, whether it is a real triple store if it sits on top of relational database, or if it is just an emulation. But they have their system has been developed a long time ago, and they are still supporting it. The Oracle NoSQL thing, which is a big data KeyValues store, you had it on your slide.
Yeah. Now, is it a mix and match sort of thing, where, in other words, you is the NoSQL from Oracle like truly a separate product, or is it something that you can use with an existing Oracle database system, like some of the newer versions?
They are actively, initially it was something that was developed completely separately because it was built in its core was Berkeley DB technology that they acquired a while ago, which was a simple key value store, like file-oriented key value store, and they just built their system on top of that. It was written completely in Java, as opposed to their core database. And initially there were not many intersections, but then they developed this new version 2, which they released recently, and it integrates much better with it. And they also have a hardware-software solution. They call it Big Data, if I'm not mistaken. This is a huge server, a rack rather, with multiple blades in it, where they have a bunch of different things installed, including Hadoop from Apache for MapReduce processing. They have NoSQL component there and have their regular database, and with this thing goes a system that have it all tightly integrated.
Gotcha. So it basically with their solution, it's not truly an all or nothing environment where you have some ability to retain that RDBMS system while still using this for the pieces where this fits. It sounds like. Now, with most people that go ahead and use NoSQL setups, what kind of split is there for them? In other words, do they put everything they have in this, or is it used just for very specific pieces of their system? Like how is that decided upon there?
Well, it's hard to say for everybody, but you have to understand that at least for now, with big data systems, you have to sacrifice a lot of rigor that regular databases have, and for certain applications this is not appropriate, whereas for other applications it's perfectly all right, and the scalability of big data systems would compensate for the for the lack of those other for this other rigorness. But
this isn't something that would ever be used for a storefront or something like that, for a website storefront or an e-commerce system, right? It doesn't have that relational integrity that you really need for those types of systems.
Yeah. Oliver.
Probably you will have to have an addition to that, although MongoDB is marketed as a great fit for a lot of the things that you just mentioned. It is marketed as a great fit for e-commerce. It is marketed as a great fit for document processing systems, and it just depends on what functionality you want there. If you really do need relational aspects, it would be really hard, of course, to go with just only NoSQL solution.
Yeah.
Although,
can you hear me?
Yes.
All right. Yeah, this is Riaz. One use that I know of, I was speaking with Gandalf, who's now working with Spotify, as some of you might know. Gandalf used to work with Mertech. They use Cassandra. I think that's one of the NoSQL database. And what they do is that in their application, when a user logs on or loads the software, you need to download almost everything related to their likes and dislikes and previous history of what they listened to and things like that. So that it's a lot of data they store per user. And when you log on to your system, into your account, all this data needs to be available to you immediately, right? So in a scenario like that, where all your history, your favorites, all your albums you like, and your playlists, what you listened to in the past, all of those things are made available to you fairly quickly. And that's an example that I know of that uses NoSQL very effectively. And they have to use it that way.
If I can add a couple of things to that example, what is really interesting about the NoSQL solution is that when you, with a regular database, whenever you choose to expand that schema, whenever you choose to add an item to the metadata that you have for a particular user, sometimes it might be a problem because you will have to restructure your tables, and that is a blocking operation.
With this, you just do whatever you want, essentially, right?
In NoSQL world, it is imperative that schemas changing to metadata are non-blocking operations. That is the major difference, which from which a lot of pluses and minuses of those solutions stem, but sometimes it is overwhelmingly significant.
I have one more question, and this is more related to the DataFlex and the Visual DataFlex developers here. One of our resellers has been asking us, well, you need to develop a driver for NoSQL and stuff like NoSQL databases and specifically MongoDB. I didn't know much about NoSQL, that's why we kind of started looking into that. And so shed some light on this, Anton, is that why this NoSQL model doesn't fit in or fit in with the DataFlex style of coding?
It's basically the problem with, it's not really a problem, it's a trait of a NoSQL, especially big data NoSQL databases, is that the schema is something that varies from document to document. And in MongoDB, a document is just a JSON block. It's not something that you even have to define. You might want to go ahead and create some indexes, and MongoDB has a benefit of allowing developers to create as many indexes as they want, which is not the case with a lot of other NoSQL databases. But still, the document is something that is very loosely defined. It can be any number of fields defined in JSON. So mapping that to regular DataFlex structures might be problematic. I'm not saying impossible, but definitely problematic.
Well, this might be a question for the attendees, is there any scenarios where they see a use for a NoSQL database in their environment? Anybody has any opinion or thoughts on that?
Another thing in relation to this that I was curious about, Anton, if anyone, we can see if anyone responds to that. It kind of seems like, you know, especially looking at you know, some of the items that are listed on this slide here, some of the NoSQL stuff, it almost seems like the wild west of data right now. Is there standards in place for like how you query this, or is every vendor doing it quite differently? You know, is there anything like a SQL 92 standard in place?
In big data, there are no really the querying part is definitely a Wild West thing, because there is sometimes you don't have a way of actually querying more than one record in some of the implementations. Sometimes there is a query language. For instance, in MongoDB, there are indexes that you can use to fine-tune your queries for finding certain things, whereas in Oracle, you only have a primary key which will lead you to your which will lead you to a bunch of your key value pairs, but you can say you can split your key in several parts and use a wildcard search on the parts that go on the right. So in big data world, there is no standard for querying. Whereas in semantic web systems, in triple stores, there are standards, and the most popular query language is probably Sparkle. And there are a bunch of other standards like Resource Description Framework, RDF, OWL Web Ontology Language, and so forth. So they have they are much more structured.
Gotcha. We got a response on that, Riaz, here from Todd Forsberg. You guys can probably see it on my screen.
Maybe Todd can Todd, you're unmuted if you want to speak up and share that thought with everybody. No mic.
No mic.
All right.
With that, that's an interesting what he's mentioning here about using it. That's kind of one of the areas I had imagined some people might be interested in. If you're looking at, for your application, being able to collect statistics about maybe how users are using your application, where they're clicking, where they're getting stuck, how long they're staying on screens, various things like that. It seems like something like this could end up being a good way of storing that information that maybe otherwise isn't very structured, and you would just be hitting it nonstop. So I can kind of see that use case here.
Yeah. Well, Oliver, did you read the question? Because the others might not be able to see that. So
the original question he asked was, item that he mentioned was that he's currently using CouchDB for storing application events like logging error messages, etc. And he also mentions here that we record the time it takes to run business processes with it.
Now, how are you, is the application written in Dataflex, Todd?
There we go. Yes, it is. So are you accessing it through like an ODBC layer or something like that? Through a RESTful interface. So he's using like a web interface for it. Interesting. So the CouchDB actually provides an interface for that then through so a RESTful HTTP interface. So essentially sending like a post to a web server that's doing it, and he's doing this from VDF.
Okay. Now, why did you decide to use CouchDB or a NoSQL database for that?
Exactly the reasons we kind of went over. Unstructured data, and it's very fast.
Yeah. Cool. So that's one pretty good example of using that.
Yeah.
And was there any particular reason for choosing CouchDB over others?
People are talking about using it for storing things like GPS data and items like that also.
Was there any particular reason you chose CouchDB, Todd?
So he mentions that he played around with Mongo also, but Couch was a little easier to use.
Okay. Cool.
I did have another question here for Anton. One of the terms that came across, that seemed to be used a lot in relation to this was with they talk about MapReduce processing. Can you explain to us what MapReduce processing is in relation to this, Anton?
Well, MapReduce term it started to be used with in the context of NoSQL databases. I believe with the release of Google's white paper when they described their way of processing their search data, web search data, and the catchy phrase behind this, behind the idea is that you should be moving calculations towards data, not the other way around. So the idea was to, if you already have data sitting on different machines, since this whole NoSQL big data storages, they are clustered by definition. So, and if you need to process all that data, why not make your nodes work for you as opposed to just store the data? So the idea was to send small little morsels of code towards each node for it to for each of those nodes to process those, and then you would aggregate the result. The parallel processing part is map, and the aggregation part is reduce. So basically, it's the process of parallelizing your computations by splitting them into parts that are easily parallelized, and then into parts where the results of those parallelized computations will be aggregated. Some of the systems, initially with Google, MapReduce was not really related to their big table database. MapReduce in their implementation was rather a trait of their file system, GFS Google File System, and it was built on top of it, whereas the database was something sitting on the side, and those MapReduce processes were of course able to read and write from the database, but they were like separate entities. And some implementations share the same separation of those concepts, like for instance famous Apache Hadoop and HBase, HBase being the database and Hadoop being the file system with MapReduce capability. And some systems, like for instance CouchDB or all the other databases that are written in Erlang, they have MapReduce as their integral part because it is just so easy to do this in Erlang. It was basically built for the purpose of distributed computation, concurrent computations.
Gotcha. So we also have another note that was sent to me from Will, and he mentions that this sort of stuff is popular with big banks. And Will, I think we got you unmuted. Can you maybe describe where you've heard of it being used in those cases?
I don't know if I'm still muted.
Oh, yep, we can hear you now.
Okay. Well, I know that one of my friends who works with a big London bank is using Hadoop, but I'm not exactly sure in what area he's using it, but they do a lot with Hadoop in order to, well, use high-speed data, as in they need very fast, very unstructured data. So they have huge amounts of data that they need to process, and they do that with Hadoop clusters. But I really don't know exactly what he's doing. I would have to ask him. But I know he's busy with that all the time.
Gotcha. So, and most likely in that case, they're probably using a combination then of that again with other more structural systems, relational systems in place.
Of course.
Gotcha. So, Anton, were you able to? One of the other things I had down here was, were you able to come up with any other examples of where NoSQL may be used by some of these smaller businesses, by customers, not the Facebooks and Craigslists of the world, where they're using it?
Well, we already kind of mentioned the clickstream example, which can be used for actually multiple applications. You can do this for, say, web activity analysis. You can do this for software testing. That's like a popular application. You can do it for market research, for employee productivity. In all those cases, you need to process loads of unstructured information, and in different cases, you need different things. Like, for instance, with software testing, you really need to record all the things verbatim with all this data, with all the timestamps and additional information that is required, whereas, for instance, for market research purposes, you might want to approach it from triple store side and just log the simple subject predicate object triples for later analysis. Along those lines, and of course any application in which you end up with loads of unstructured data, if you for instance need to process documents of various formats and you need to actually be able to make sense of them, NoSQL big data approach is a very good fit.
Gotcha. Okay, well, I think that gave everyone a pretty good overview on this. If you have any other questions, get them in now. And you know, we wanted to try and get you guys a basic understanding of this, get you thinking about it, and where you can might be able to use some of this in you know, your specific application or business. I want to thank everyone also for participating today, and we'll certainly be sending out some information about our next Campfire. We don't have a topic lined up just yet, but of course, if you have anything that you'd like to suggest for that, we'd love to hear that. And we'll probably try and get that scheduled. You'll be hearing about that in the next couple of weeks, I'd imagine, with schedule for the next one. So if you have topics, please make sure you send them to us. And thank you guys all for coming.